Hello viewers, in today's lecture we are going to solve some important problems related to application of derivatives. So the first question is related to the topic increasing and decreasing functions. So let us first take this problem. Show that y is equal to log 1 plus x minus 2x divided by 2 plus x greater than minus 1 is an increasing function throughout its domain. So viewers, here we have to show that this function y is an increasing function. Now for a function y is equal to fx to be increasing function if the derivative of f is greater than 0. So we have to write this condition for a function to be an increasing function. Clear? And for decreasing we have to write f dash x less than 0. Clear? So let us see that this function is an increasing function. So what we will do, we will find the derivative. So dy over dx is the derivative of log 1 plus x is 1 over 1 plus x, and then we have minus 2, and we have to find the derivative of this function, that is 2 plus x, right? So here we will apply the rule of quotient, derivative of quotient of two functions. So we have 1 over 1 plus x minus 2, and here we have 2 plus x, then derivative of x is 1 minus x, derivative of 2 plus x is 1, and divided by 2 plus x square, right? So this is 1 over 1 plus x minus this is 2 times 2 plus x. 2 plus x times 1 is 2 plus x, then we have minus x, then we have 2 plus x square. Now x and x get cancelled, so we have 1 over 1 plus x minus this is 4 divided by 2 plus x square, right? Okay, so here's here now we'll take the LCM of these two terms. So we have 1 plus x and 2 plus x square, and then we'll have 2 plus x square here, and then we have 4 times of 1 plus x. Clear? Now if we simplify this expression, we have 4, this is 2 plus x whole square, that is 4 plus x square plus 4x minus 4 and minus 4x, and this is 1 plus x, this is 2 plus x square. Now 4x get cancelled, 4 and 4 get cancelled, so we have x square over 1 plus x, 2 plus x whole square. So viewers, here when we solve this question, the important thing is to find the derivative. So once we correctly find the derivative, things becomes easy, right? So now here the derivative is x square over 1 plus x times 2 plus x whole square. Now for a function y to be an increasing function, f dash x should be greater than 0, or dy over dx must be greater than 0. Now here we see that x square is always x square is always greater than 0, right? And 2 plus x whole square, 2 plus x whole square is always greater than 0. Or in other words, we can say that this term and this term, that is x square x square over 2 plus x whole square is always positive. This term is always positive whenever x is greater than minus 1, right? X is greater than minus 1. So the only term which is left out is 1 plus x. So therefore we can say that this derivative dy over dx is greater than 0 if and only if this term, that is 1 plus x, is greater than 0, right? Or if we take this 1 to this side, we have x greater than minus 1. So this is the required condition for this function to be an increasing function, right? So viewers, here I would like to mention one more thing, that this is a square term, this is also a square term, and the square of any term is always greater than or equal to 0. For example, here x square is greater than 0 or equal to 0 if x is 0, and 2 plus x whole square is again greater than or equal to 0. Equal to 0 when x is minus 2, then this term will be 0, that is 2 plus x is 0, and when x is 0, then x square is 0. So what I mean to say is that these two terms are always positive, so the deciding term for dy by dx to be greater than 0 is this term, that is 1 plus x. So for dy by dx to be greater than 0, 1 plus x must be greater than 0, or if we solve it, then we have x greater than minus 1. So if we take the real number line, here we have minus 1, here we have minus infinity, and here we have plus infinity. So x is greater than minus 1 implies that we have to go to this side, right? So whenever x belongs to minus 1 to infinity, then this function is always increasing, right? Now viewers, let us take this problem. Find the slope of the tangent at x equal to 4 for the curve y equal to 1 over x minus 3, where x is not equal to 3. Now this problem is from the topic tangents and normals. Tangents and normals, right? Okay. So here's the equation of the curve is y is equal to 1 over x minus 3. So what is slope? We know that slope is given by the derivative of y with respect to x. So again, the important thing is to find the derivative. So the derivative is dy over dx is we can write it as x minus 3 raised to minus 1. So we have minus 1, x minus 3 minus 2, and by chain rule we have 1, right? So this is minus 1 over x minus 3 whole square. So yes, this is the slope of the tangent, and we have to find the slope at x equal to 4. So what we will do, we'll write x equal to 4 here, and we'll substitute the value of x as 4 in this expression, that is minus 1 over 4 minus 3 square. So we have minus 1, and this is 4 minus 3 is 1 square, that is minus 1 over 1, that is minus 1, right? So this is the required slope. Suppose we have to find the slope at x equal to say 2, then what we will do, we'll substitute x equal to 2 here. So we have minus 1 over 2 minus 3 square. So again we have minus 1, 2 minus 3 is minus 1 square, that is minus 1, minus 1 square is 1, so we have minus 1. And always remember that the curve is not defined at x equal to 3, so the slope is not defined here, that is minus 1 over, if we have x equal to 3, then the slope will become minus 1 divided by 3 minus 3 square. So we have minus 1 and 3 minus 3 is 0, 0 square is 0, so the slope is not defined, right? Now viewers, this problem is again from the topic tangents and normals. We have to find the slope of the normal to the curve. Here we have the slope of the normal, right? So here's what we will do. We'll again find the derivative, that is dy over dx. So the derivative of this function is, we'll take this to the numerator, that is minus 1, and if we differentiate it, then we have minus, we have x square minus 2x plus 3 minus 2. First of all, we'll apply the formula d by dx of x raised to n, that is nx n minus 1, and then by chain rule we'll differentiate this function x square minus 2x plus 3, which is 2x minus 2, right? Derivative of x square is 2x, derivative of 2x is 2, right? So we have a minus, and taking this to the denominator, so we have this as the derivative or the slope. So this represents the slope of tangent. Always remember, this is the slope of the tangent, and if we have to find the slope of the normal, then what we will do, we will take the reciprocal of this expression and multiply it by minus 1. So now let us find the value of dy over dx at x equal to 2. So we'll substitute the value of x as 2 in this expression. So we have minus, this is 2 2s are 4, 4 minus 2 is 2, and then we have 2 square is 4, then we have 2 2s are 4, and then we have plus 3, and this is a square, and we have minus 2, 4 4 get cancelled, we have 3 square, that is 9. So here's dy over dx at x equal to 2, let us denote it by m. So this is the slope of tangent. Always remember, this is slope of tangent, but we have to find the slope of the normal. So what we will do, we know that slope of tangent, say this is mt, slope of tangent times slope of normal is equal to minus 1. So the slope of tangent is minus 2 by 9 multiplied mn equal to minus 1. So if we solve it, we get mn is equal to minus and minus get cancelled, so we have 9 by 2. So this is the required slope of the normal to this curve at x equal to 2. Now viewers, this problem is again from tangents and normals. We have to find the slope of the tangent to the curve x equal to 1 minus a sine theta and y equal to b cos square theta at theta equal to pi by 2. Now here the equations are given in the form of parametric equations, so we have to find the slope, and slope is given by dy by dx, and dy by dx is given by dx over d theta, it is dy over d theta divided by dx over d theta, right? So here the equations are given in parametric form. So in parametric form we have the parameter theta, so dy over dx is dy by d theta divided by dx over d theta, right? So now what is dy by d theta? Dy by d theta is b. We'll differentiate it, so we have 2 cos theta and then we have minus sine theta, right? Now divided by dx over d theta is 0 minus the derivative of 1 is 0, so we have minus a, derivative of sine theta is cos theta, right? Now if we simplify it, we have minus 2b sine theta cos theta, and then we have minus a cos theta. So here's cos theta and cos theta get cancelled, minus and minus get cancelled, so we have 2b over a sine theta, right? So therefore the slope of tangent is given by 2b over a, and sine theta is sine of pi by 2, because we have to find the slope at theta equal to pi by 2. Sine pi by 2 is 1, so we have 2b over a times 1, that is 2b over a. So this is the slope of the tangent. Suppose we have to find the slope of the normal, then what we will do? We will again use the slope of tangent times slope of normal equal to minus 1. So slope of normal is equal to minus 1 divided by mt. So we have minus 1, mt is 2b by a, so we have minus a upon 2b, right? Now viewers, let us take this problem which is from increasing and decreasing functions. So find the intervals in which the function f of x is equal to minus 2x cube minus 9x square minus 12x plus 1 is increasing or decreasing, right? So here again the derivative plays an important role. So let us take it as y. So let us first find the derivative, that is dy over dx. Now the derivative is minus 4x, it is 6 minus 6x square minus 18x minus 12. Now this can be written as minus 6 x square plus 3x plus 2, right? Now if we factorize this by middle term, we have x plus 1 and we have x plus 2. Now viewers, what we will do, we'll find the turning points or the critical points. So the turning points can be obtained by putting the derivative equal to 0, or we take f dash x equal to 0. So we have minus 6 x plus 1, here we have x plus 2 equal to 0. So we have two roots, minus 1 and minus 2. Now there is a definite process here, and the process is we have x equal to minus 1 and minus 2, and let us plot these 2 points here. We have minus 2 here and minus 1 here. So here we have minus infinity and here we have plus infinity. Now what we will do, see here we have the negative sign. I have already explained all these things in my previous video, so for details you can watch those videos. Now here I am not taking why we are taking this method or the sign convention, because I have already explained it. So here we have the negative sign. So what we will do, we will start from negative sign, right? So here we have negative sign, then we have plus sign alternatively. So we have minus, plus, and then we have minus. So here see where we have minus sign, the function is decreasing. Here it is decreasing, here also it is decreasing, and where we have the positive sign, the function is increasing, right? So therefore the function f of x is increasing when the derivative is greater than 0. So what are the intervals? F dash x is greater than 0 means we have to locate the interval where the derivative is positive. So we have x belongs to minus 2 to minus 1, right? So in this interval the function is increasing, right? And where we have negative sign the function is decreasing. So therefore fx is decreasing if f prime of x is less than 0. So we have x belongs to minus infinity to minus 2, minus infinity to minus 2, and then we have to leave this interval, then we'll directly come to this interval. So we have union here, so we have minus 1 to infinity, right? So this is the interval in which the function is increasing, this is the interval in which the function is increasing, and always remember we have to write the condition when the function is increasing and when the function is decreasing, right? Now viewers, I am taking this question but with a slight change. Suppose we have to find the intervals in which the function y equal to fx. Instead of taking this function, let me make some changes here. So we are removing these negative signs, and let us take this as positive and again this as positive. And now this question has become a new question, and we have to find the intervals in which this function is increasing and decreasing. Now let us see what are the changes we can make in this solution, right? So this may be a very useful question for you. So what we will do, we'll find the derivative. So when we'll find the derivative, see, we'll not have this sign, then we have here positive sign, here also we have positive sign, right? Now if we take 6 common, then we'll not have this negative sign, again we'll not have negative sign. So here we have, see, in the previous question we had here a negative sign, now we'll have the positive sign. Now for the function to have turning points or stationary points, the derivative should be 0. So we have f prime of x is 0. So now here we will not have the negative sign. So the roots are, or the stationary points are minus 1 and minus 2, right? Now see, we have shown these 2 points on this real number line. Now since we have here the positive sign, see, in the previous example we had negative sign here, so we started from the negative sign. Now here we have the positive sign, so what we will do, we will start from the positive sign. So here we have the positive sign, then here we have the negative sign, right? And then we have the positive sign. So where we have the positive sign, the function will be increasing. Here we have negative sign, so we have decreasing function, and here we have the positive sign, so we have increasing function, right? So therefore fx is increasing when f prime of x is greater than 0. So we have here x belongs to minus infinity to minus 2 union, here we have 1, so we have minus 1 to infinity, right? And fx is decreasing if f prime of x is less than 0. So x belongs to, now we have the interval minus 2 to minus 1, right? So here we see that the intervals are reversed whenever we have here the positive sign. Clear? So we with the help of or comparing these 2 types of questions, we have seen how to find the intervals in which the function is increasing and decreasing, right? Now viewers, let us take this problem, and this problem is from maxima and minima. Find the maximum and minimum values if any of the function. So here we are given a function, and we have to find its maximum and minimum values if it exists, right? Now we have seen in our earlier videos in detail that how to find the maximum and minimum values by using the definition of maxima and minima. Actually there are three methods, right? The first one is by simply guessing at the function, or by making use of the definition of maxima and minima, and the second method is the first derivative test. This is the first derivative test, and the third method is second derivative test, right? So viewers, sometimes it is not possible to find the maximum and minimum values by making use of the definition. Then we switch over to these two methods, right? But in this question I am going to use the definition, right? So here we have to find the maximum and minimum values. Now viewers, see, this is the absolute value function, or the modulus function, and we know that this function is always greater than 0 or equal to 0, right? Okay, so see, here I am going to use the definition, right? So this mod of x plus 2 is always greater than or equal to 0. Now if we subtract, let us say this is inequality number 1. Now subtract minus 1 both sides. So when we subtract minus 1 on both sides, we have mod of x plus 2 minus 1 greater than 0 minus 1. So this is mod of x plus 2 minus 1 greater than minus 1. And see, this is f of x. So whereas we have f of x is greater than or equal to minus 1, right? So what conclusion we can draw from this expression? So the function is greater than or equal to minus 1. So it means the minimum value of the function is minus 1, and there is no maximum value, right? There is no maximum value. So the minimum value is minus 1 because fx is greater than or equal to minus 1. So the minimum value is minus 1 and there is no maximum value. Now viewers, here I would like to mention one more thing. Now see, here the minimum value is minus 1, and let us see at what value of x this minimum value occurs. See, f of x is minus 1, so if I substitute here, so we have minus 1 and we have mod of x plus 2 minus 1. Minus 1 get cancelled, so we have mod of x plus 2 is 0. So this is x plus 2 is equal to 0. So x is minus 2, right? So the minimum value of this function is minus 1. Always remember, the minimum value is minus 1, and this minus 1 occurs, this value occurs at x equal to, this value occurs at x equal to minus 2, right? So viewers, this question we have solved by using the definition. Now viewers, let us take this problem. Here we have to find the maximum and minimum values, if any, of the function fx is equal to minus x minus 1 whole square plus 1 plus 10. Now again I will make use of the definition, right? So viewers, if I make use of this definition, then let us see how we can proceed. So here we know that the square of any quantity is always positive. So we can write x minus 1 square is always greater than 0 or equal to 0, because at x equal to 1 this expression will become 0. Therefore we have this equality sign, right? So x minus 1 square is greater than or equal to 0. Now here we have minus sign, so let us multiply both sides by a minus sign. So we have minus of x minus 1 square. So what happens here? So the sign of this inequality gets reversed, right? Now here we have 10, so we'll add 10 to both sides. So we have 10 minus x minus 1 square, and here we have 10 plus 0, right? So here see, this expression is this expression, right? So both are same. So for this we will substitute f of x, and here we have 10 plus 0 is 10. So the function is less than or equal to 10. Now in this case the maximum value of fx is 10, right? Because the function cannot go beyond 10, so it is less than 10 or equal to 10. So the maximum value of fx is 10, and there is no minimum value. There is no minimum value, right? And let us see for what value of x the maximum value of fx is 10. So in this expression we'll substitute 10. So we have 10, and we have minus of x minus 1 square plus 10. 10 and 10 get cancelled, so we have 0 minus x minus 1 square. This is x minus 1 square equal to 0, so we have x equal to 1. So at x equal to 1 the maximum value of fx is 10, and there is no minimum value. Now viewers, let us see this very important question, important and very interesting question. Here we have to find the maximum and minimum values, if any, of the function. So again here I am going to use the definition. Now we know that the value of sine theta lies between minus 1 and 1, right? So here what we have 2x, so we have minus 1, and here we have sine 2x, and we have this inequality, right? So from trigonometry we know that the value of sine theta lies between minus 1 and 1, right? Now see, here we have sine 2x plus 4. So if we add throughout plus 4, that is adding 4 throughout, right? Adding 4 throughout, we get minus 1 plus 4, and here we have sine 2x plus 4, and here we have 1 plus 4. Now 4 minus 1 is 3, and here we have sine 2x plus 4, and for sine 2x plus 4 we can write f of x, and here we have 5. So here see, the value of fx lies between 3 and 5. So this is the minimum value, and this is the maximum value, right? Maximum value. So fx lies between 3 and 5. So the minimum is 3 and maximum is 5, right? Now viewers, let us take this problem. Here we have to find the maximum and minimum values, if any, of the function fx equal to cos 2x plus 4. Now in the previous question we have discussed that the maximum and minimum values of sine 2x plus 4. Now here again I am making use of the definition. So we know that cos 2x lies between -1 and 1, right? Now viewers, here we see that cos 2x lies between -1 and 1. Now see, here we have cos 2x and here we have 4. So we'll add 4 throughout, right? So if we add 4 throughout, we have -1 plus 4, and here we have cos 2x plus 4, and then we have 1 plus 4. So this is 4 minus 1, 3, and cos 2x plus 4 is equal to f of x, and here we have 5. So now we see that the function f of x lies between 3 and 5. So this is the minimum value and this is the maximum value, right? So we can write the f of x maximum value is 5 and f of x minimum value is 3, right? Now viewers, I am taking a very important question here, and this question also related to maxima and minima. Now here we have to find the local maximum and local minimum values, if any, of the function, right? So what we will do here, we'll find the derivative of this function, that is f prime of x. This is 3x square minus 12x plus 9, right? Now for the turning points, or for the critical points, we have f prime of x is 0, right? Now f prime of x is 3x square minus 12x plus 9 equal to 0, which is equal to x square minus 4x plus 3 equal to 0, and if we factorize it, we get x minus 3 and x minus 1 equal to 0, so we get x equal to 1 and 3. Now viewers, here I would like to mention that here I am not going to use the definition, but here I will use this method, that is second derivative test. So for second derivative test, we have to make use of the second derivative. So let us find the second derivative of this function. So the first derivative, f prime of x, is 3x square minus 12x plus 9. So the second derivative is 6x minus 12. Now we have the turning points as x equal to 1 and 3. So let us first take the value of x is equal to 1 and substitute it in second derivative, right? So f double prime of 1 is 6 times of 1 minus 12, that is 6 minus 12 is minus 6, and this is less than 0. So therefore by second derivative test, we see that x equal to 1 is a point of local maxima, right? Okay, now let us take x is equal to 3, right? Now substitute x equal to 3 in the second derivative. So f double prime of 3 is 6 times of 3 minus 12, this is 18 minus 12, which is 6, and this is a positive quantity, so it is always greater than 0. So therefore by second derivative test, x equal to 3 is a point of local minima, right? So what is second derivative test? Second derivative test is if we have a function fx, we find the first derivative, then we find the second derivative, and if we put f prime of x, that is the first derivative, equal to 0, and we solve it for x, we get the critical points or the turning points, and then we find the second derivative and we substitute the values of the turning points in the second derivative, and if the second derivative the value of second derivative is greater than 0 or it is positive, then the function is maximum, and if f double prime of x is less than if it is f double prime of x is greater than 0, then it is minimum, and if f of double prime of x is less than 0, then it is maximum, right? Okay, so here x equal to 1 is a point of local maxima, x equal to 3 is a point of local minima, and the value of local maximum value is, so x equal to 1 is a point of local maxima, so we have f1 is equal to 1 cube minus 6 times of 1 square plus 9 times of 1 plus 15. So we have 1 minus 6 plus 9 plus 15, and this is minus 5 plus 24, and this is 24 minus 5 is 19. So this is a local maximum value, right? And this value occurs at x equal to 1. And now we have x equal to 3 is a point of local minima, so we'll take x equal to 3 now, and we'll find f of 3. Now f of 3 is 3 cube minus 6 times 3 square plus 9 times 3 plus 15. Now this is 27, and this is 54, this is 27, and this is 15. So 27 plus 27 is 54. So where's these three terms get cancelled, so we have 15, right? So this is the local minimum value of the function, right? And this value, local minimum value, occurs at x equal to 3, right? Okay, so here we have used the second derivative test. Now viewers, let us take this problem. The cost function for a company to manufacture a certain quantity is given by C of x is equal to 300x minus 10x square plus 1 over 3 x cube. Now we have to find out x if average cost is minimum. So let us first see what is meant by average cost. So the average cost AC is given by Cx divided by x, right? So this is the formula for average cost. So the cost function is 300x minus 10x square plus 1 over 3 x cube. So this is divided by x. So average cost becomes, if we take x common, so we have 300 minus 10x plus 1 over 3 x square, right? Because if we take x common, then this x and this x get cancelled. See, we can write it like this. So this x and x get cancelled. So we have 300 minus 10x plus 1 over 3 x square. So now this is the average cost. So let us denote this average cost by say A, right? Okay. Now we have to find x if average cost is minimum. So what we will do, we will find dA over dx. So what is dA over dx? The derivative of this function is here we have 0, then we have 10, and then we have 1 over 3 times 2x, right? Now for a to be minimum, dA over dx must be 0, right? So therefore this function, that is minus 10 plus 2 by 3 of x is equal to 0, because dA over dx is we are going to put dA over dx equal to 0. So we have minus 10 plus 2 by 3 x equal to 0. So if we solve it, we get 10 is equal to 2 by 3x, and x is 30 over 2, that is 15, right? So the value of x is 15. Now we have to see whether this cost is minimum or not. So we'll make use of the second derivative test. So let us find the second derivative of a. So d2a over dx2 is equal to, the derivative of minus 10 is 0 and the derivative of x is 1. So we have 2 by 3, and it is a positive quantity, so it is greater than 0. So therefore we have a as minimum, right? And the value of a as minimum occurs at x equal to 15, right? So the required value of x is 15. Now viewers, let us take this problem. Find the absolute maximum and minimum values of this function f of x, x cube minus 3x square plus 3x plus 8 in the interval 0 to 10. Now we have this function, so again we'll find the derivative. So the derivative of fx is 3x square minus 6x plus 3, right? Now for the critical points, f dash x should be 0 or f prime of x is 0. So we have to solve this equation, that is 3x square minus 6x plus 3 equal to 0. Now dividing by 3, we get x square minus 2x plus 1 is equal to 0. So this is x minus 1 whole square. So we have x minus 1 equal to 0. So we have x equal to 1. So the turning point or the critical point is x equal to 1, right? Now let us see whether this point x equal to 1 is a point of maxima or a point of minima. So for this we have to find the double derivative. The second derivative of fx is we'll find it from here. So we have 6x minus 6, right? Now if we substitute here x equal to 1, so we have f prime of 1 is equal to 6 times of 1 minus 6. So we have 6 minus 6, that is 0. So here we see that the double derivative at x equal to 1 is 0. So therefore we conclude that x equal to 1 is a point of inflection, and we declare that x is equal to 1 is neither a point of maxima, nor a point of minima, right? Okay, so therefore in order to find the absolute maximum and absolute minimum of this function, we will now calculate the value of this function at 0 and 10. So therefore at x equal to 0, the value of the function is f of 0 is 0 cube minus 3 times of 0 square plus 3 times of 0, and then we have plus 8, so we have 8, right? And at x equal to 10, the value of f of 10 is given by 10 cube minus 3 times of 10 square plus 3 times of 10 plus 8, right? Now which can be equal to, or this is calculated as 1000. This is 10 cube is 1000 minus 100 times 3, it is 300. Then we have 30 plus 8, right? So this is 730 plus 738, right? Now viewers, the maximum value of this function or the absolute maximum is 738. This is the maximum value which occurs at x equal to 10, and the minimum value is 8, which occurs at x equal to 0, right? So this is the minimum value, this is the maximum value, and this is the minimum value. Hence the absolute maximum is 738, which occurs at x equal to 8, and the absolute minimum is 8, which occurs at x equal to 0. Now viewers, let us take this problem. The cost function of a firm is given by Cx is equal to 200x minus 20 by 3 x square plus 2 by 9 x cube, where x is the output. Now we have to find the output x if marginal cost is minimum. Now we know that the marginal cost is given by the derivative of cost function, right? So the derivative of cost function is calculated as d by dx of 200x minus 20 by 3 x square plus 2 by 9 x cube, right? So the derivative is this is 200 times 1, we have 20 by 3, this is 2x, and this is 2 by 9, and this is 3x square, right? So MC, that is marginal cost, is 200 minus this is 40 over 3 x plus, that is 3 3s are, so we have 2 by 3 x square, right? So here's this is the marginal cost, and let us denote it by m. Now we have to minimize this marginal cost. So what we will do, we'll find dm over dx. Now dm over dx is the derivative of this function. So the derivative of 200 is 0. We have minus 40 divided by 3 times 1, and then we have 2 by 3 times 2x, right? So this can be written as minus 40 over 3 plus 4 divided by 3 times x. Now for m to be minimum, dm over dx must be 0. So therefore this expression, that is minus 40 over 3 plus 4x divided by 3, should be 0. So if we solve it, we get minus 40 plus 4x equal to 0. So 40 is equal to 4x, and x is equal to 10, right? Now let us see whether this marginal cost function is minimum at x equal to 10 or not. So what we will do, we'll find the second derivative of m. So the second derivative is d2m over dx2 is, we'll differentiate this function. So we have 4 upon 3, because the derivative of minus 40 divided by 3 is 0, and the derivative of x is 1, so we have 4 by 3, and this is a positive quantity, so this is greater than 0. So therefore by second derivative test we can say that the marginal cost is minimum, right? So this marginal cost is minimum at x is equal to